Hello everyone, in this video I am going to explain about Colpitts oscillator. Let's discuss how the Colpitts oscillator is constructed. So we have a resistance R1 and R2 as well as RE which provides a proper DC biasing to the transistor, and we have a coupling capacitor CC1 and CC2, and we have an emitter bypass capacitance, and the feedback network consisting of the capacitance C1, capacitance C2 as well as the inductance or the inductor L. So the feedback network consists of capacitance C1 and C2 and inductor L, which determines the frequency of oscillator. So the phase difference between, can you observe three terminals here? So this is terminal 1, terminal 2 and terminal 3. So the phase shift or the phase difference between the two terminal is always 180 degree. So the frequency of oscillation for the Colpitts oscillator is 1 by 2 pi root of L into C equivalent, and the C equivalent is given by C1 C2 by C1 plus C2. First we have to find the frequency of oscillation. So in order to find the frequency of oscillation, so in the Colpitts oscillator, Z1 and Z2 are capacitance, okay, capacitive reactance, and Z3 is an inductive reactance. In the previous case we have discussed about the Hartley oscillator. There Z1 and Z2 are inductive reactance and Z3 is a capacitive reactance. So in case of Colpitts oscillator, it is Z1 and Z2 are capacitive reactance and Z3 is nothing but your inductive reactance. So we can write Z1 as minus J by omega C1 and Z2 has minus J by omega C2, as well as we have Z3 which is nothing but J omega L. And the general equation for the oscillation is given by HIE into Z1 plus Z2 plus Z3 plus Z1 Z2 into 1 plus HFE plus Z1 Z3, which is equal to 0. So we know what is Z1, Z2 and Z3. We have to substitute Z1, Z2 and Z3 in this general equation. So once you substitute, we'll get an equation 2. Okay, so in order to find the frequency of oscillation, we have to equate the imaginary part as 0. So this is your imaginary part and this is your real part. So once you equate the imaginary part as 0, we'll be getting HIE. HIE is nothing but your input impedance and HFE is the current gain. Okay, so HIE into minus 1 by omega C1 minus 1 by omega C2 plus omega L. We have to equate it to 0 in order to find the frequency of oscillation. So if you take this, if you bring this HIE to the right hand side, it becomes 0. So minus 1 by omega C1 minus 1 by omega C2 plus omega L, which is equal to 0. So omega L is given by 1 by omega C1 plus 1 by omega C2. So omega square. So how can you write this omega square L? You can take omega as common and you can write 1 by C1 plus 1 by C2 and then bring this omega that side, it becomes omega square. So omega square L is given by 1 by C1 plus 1 by C2. So how can you write this? C1 plus C2 by C1 C2, right? Then how can you write omega? So omega square is given as, so this is nothing but what? C1 plus C2 by C1 C2 is nothing but C equivalent, right? So it is 1 by C equivalent. So if it is 1 by C equivalent, then omega square is given by 1 by L into C equivalent, and omega is given by 1 by root of L into C equivalent, and already we know omega is equal to 2 pi f. So you just substitute omega is equal to 2 pi f, and the frequency of oscillation f is given by 1 by 2 pi square root of L into C equivalent. So once we find the frequency of oscillation, we have to find the condition for oscillation. In order to find the condition for oscillation, we have to equate. So in order to find the frequency of oscillation, what we have done? We have equated the imaginary part to 0. And in order to find the condition for oscillation, we have to equate the real part to 0. Okay, so this is a real part. Real part is minus 1 by omega square C1 C2 into 1 plus HFE plus L by C1, which is equal to 0. So we have to equate this to 0. So once you equate it, so you just bring this term that side, it becomes positive. So L by C1 is given by 1 plus h of E by omega square C1 C2. So C1 C1 get cancelled, and then I am just bringing this omega square that side, it becomes omega square L, which is given by 1 plus h of E by C2. Now we have to substitute omega square L from equation 3. So equation 3 represents omega square L. Omega square L is given by C1 plus C2 by C1 C2. So we have to substitute omega square L here. So once you substitute omega square L, your C2 and C2 get cancelled, and I have written the remaining term, and the remaining term is C1 plus C2 by C1. It is written as 1 plus C2 by C1. So this 1 and 1 get cancelled, and the remaining current gain is h of E is given by C2 by C1. Thanks for watching.